Hello students, in this video I will go through exercise U4A07A where I will be applying properties of sides, angles, and diagonals to identify kites. Okay, so let's take a look. If ABCD is a kite, find each measure. So I know that in a kite, the diagonals will be perpendicular to one another, however, it will not be bisecting one another. So in this case here, if I'm asked to find out what the length of AB is going to be opposite of that right angle. This is a right triangle. I have a small right triangle here. This side here has to be 5. This is another one of those instances where the 3, 4, 5 triangle come into play. Okay, so this is a kite where I have two pairs of adjacent sides that are congruent. So therefore, to find out what angle C is, this angle over here must be 85 degrees. And if that's the case, then I know that 85 plus 120 plus x is equal to 360, considering that this is a quadrilateral, right? So 85 plus 85, that is 170. 170 plus 120, that's 290. If I subtract both sides by 290, I end up with x is equal to 70. So angle C is equal to 70. Okay, moving on. JL is, I need to find JL. KP is equal to 4. So this little thing here is 4. And PM is equal to 7. So this thing is equal to 7. This is an isosceles trapezoid. It's not a kite. So the diagonals are not going to be perpendicular, but I do know that the diagonals will be congruent. So if KM is equal to 11, JL therefore is also going to equal to 11. PW is what I need to find. If XZ is equal to 18, XZ is equal to 18. Okay, so this is again an isosceles trapezoid. XZ is the full diagonal, and PY is equal to 3. So this guy here is 3. And I need to find PW, which is this guy right here. So if PW plus 3 is equal to 18, PW therefore must equal to 15. All right, 24. WXYZ is a kite. Find each measure. So I need to find out what YZ is. YZ is this guy right here. So the diagonals, one diagonal will be the perpendicular bisector of the other and not of each other. So here in this case, okay, I know that this is a right angle. The diagonal here, this should be 5, and I don't know what the other one is, okay? But that's not the point. I need to find out what ZY is. So ZY, I'm going to call that X, right? So I know that X squared plus, I'm sorry, not X squared, is equal to 5 squared plus 8 squared, which is 25 plus 64, which is 89. So X is equal to square root of 89. So ZY will equal to square root of 89. Or YZ, rather. Okay. Next, this is again a kite. So I need to find out what WP is. So because, again, the diagonals are going to be perpendicular to one another, I can apply the Pythagorean theorem, and I can call WP x. So x squared plus 4 squared is equal to 6 squared, or x squared plus 16 is equal to 36. Subtract 16 from both sides, x squared is equal to 20. Take the square root, x is equal to square root of 20, or WP is equal to 2 square root of 5. I need to find out what angle X is. So in this case here, I know that these angles over here, I'm going to call x, angle x, those two angles have to be the same. So therefore I can say that 2x plus 70 plus 56 is equal to 360. Combine like terms. I get 2x plus 126 is equal to 360. Subtract 126 from both sides, I end up with 234. Divide by 2, I end up with 117. So angle x is equal to 117. Okay. Whoops. Angle Z. So this angle down there is 90. So this is x and that's x. Actually, I'm going to call this angle Z, Z. So 2z's plus 90 plus 120, again, is equal to 360. 2z plus 210 is equal to 360. 2z is equal to 150. Z, therefore, is equal to 75. Find each measure, angle 1. Okay, so I need to find out what angle 1 is. This is a kite after all, so therefore that angle there must be 90. So angle 1 and 31 must be complementary. So angle 1 plus 31 is equal to 90. Subtract 31 from both sides, angle 1 is equal to 59. This is a trapezoid. So I'm asked to find out what BC is. So I can say x plus 13 divided by 2 is equal to 10 because I'm given the mid segment there. So x plus 13 is equal to 20. Subtract 13 from both sides, I end up with x is equal to 7. So BC is equal to 7. Given that ABCD is a rhombus, what is BD? BD. Okay, so if this is a rhombus, that means this is 5. And if that's 5 and that's a right angle, I can apply the Pythagorean theorem. But recognizing that BE is a part of a 3, 4, 5 triangle, BE therefore is equal to 3. And if BE is equal to 3, then BD is equal to 6. Given that ABCD is a rhombus, what is BD? Wait, it's the same question? Okay. So, question 21. Is the parallelogram a rhombus, a rectangle, or a square? So, for question 21, this is actually going to be just a rectangle. We can't really justify anything else because if these were perpendicular to one another, then sure, we can say that it's a square, but we can't justify anything else aside from this. This is a rectangle. The diagonals are bisecting each other, and the diagonals are congruent. Here, in this case, we can't justify what this is. This is at most, actually, this is not much of anything, because I can certainly draw the diagram, the quadrilateral, to look something like this. And this is neither a kite nor a trapezoid nor anything, right? So the diagonal is just perpendicular. So this is nothing. So it's just a regular quadrilateral. And looks like that's it.